Welcome to the deep dive. Today we're zeroing in on something I think many of us have seen, those unexpected costs with Google BigQuery.
Oh, yeah.
It's incredibly powerful for data science, reporting, AI, all that good stuff. But yeah, the pricing can sometimes bite you if you're not careful.
Absolutely. It's fantastic tech, but that pay-as-you-go flexibility, well, it means you really need to be proactive. You can't just set it and forget it from a cost perspective.
Right. So our mission today really is to give you a kind of shortcut. How do you get a handle on BigQuery spending without hobbling what you can actually do with it?
Exactly. We want to hit the key strategies for making those costs predictable.
Okay, so we've sort of boiled it down looking at the resources into two main pillars, let's say. Governance first, then technical optimization. Sound right.
That's the core of it. Governance is all about setting the rules of the road.
Rules of the road. I like that. So what does that look like in practice? What are the must-haves for governance?
Well, think of it like putting up guardrails. First off, budgets and alerts. You absolutely need to know, like immediately if spending starts spiking.
Yeah, no nasty surprises at the end of the month.
Precisely. And then query quotas. These are crucial. They basically limit how much data a single query or maybe a user per day can scan.
Ah, so that stops those accidental, oops, I queried the entire petabyte archive moments.
Exactly that. Someone queries way more than they intended. A quota can prevent that from becoming a financial incident. It's a safety net.
Okay, smart, like a data processing speed limit, sort of. What else is in this governance playbook?
Next up is role-based access control, or IAM. It's fundamental. Basically, making sure people only have access to the data and the actions they actually need for their job.
Least privilege principle. Makes sense.
Right. And critically, data retention policies. You have to ask, why are we storing data from 5 years ago if nobody's using it? That's just paying for storage you don't need.
Good point. Purge or archive it.
Archive it, delete it, whatever fits the policy. And another big one, project-level quotas. These cap the total query usage for an entire project, adding another layer of control.
Okay, so budgets, user quotas, project quotas, access control, data retention, anything else?
Yes, labels. Using labels on your BigQuery resources, like data sets and tables, lets you track costs back to specific teams, projects, or, cost centers, vital for chargebacks and just general accountability.
Right, so you know who spent what. Okay, that governance side feels pretty comprehensive. It's about setting boundaries, knowing who's doing what.
That's it. Sensible boundaries.
Now let's switch gears. Getting under the hood, the technical optimization side. How do we make our actual queries more cost-effective?
This is where some SQL know-how really, really pays off. The absolute classic mistake is select.
Selecting everything.
Selecting everything. Why pull back every single column in a massive table if you only need, say, 3 of them? Each extra column adds to the data processed and therefore the cost.
It's like ordering the entire buffet when you just wanted a salad.
Perfect analogy. Be specific. Select column 1, column 2, not select. Another big one. Apply filters as early as possible in your query. Use that where clause effectively.
So cut down the data before doing joins or aggregations.
Exactly. The less data BigQuery has to shuffle around and process in later stages, the cheaper and faster the query will be. And speaking of joins, optimizing them is key. Sometimes a different join order or type can drastically cut costs.
Okay, so be precise with columns, filter early, watch those joins. What about the data structure itself, how we set up our tables?
Huge impact there. Partitioning tables is often a game changer, especially for time series data. If your table is partitioned by date and you only query yesterday's data...
BigQuery only scans that one partition.
Precisely. Instead of scanning the whole table, it just looks at the relevant slice. Massive cost saving. And then there's clustering.
Right, clustering. How does that fit in?
Clustering physically sorts the data within partitions based on the columns you specify. So if you often filter or aggregate by, say, custom read, clustering by it, it means BigQuery can read less data because similar values are stored together.
Okay, so partitioning for date ranges, clustering for common filters or group bys, both reduce the scan size.
They work together beautifully to minimize data processed. And don't forget materialized views.
Ah, yes. MVs for those really common heavy queries.
Exactly. If you have a complex dashboard query that runs constantly, materializing it pre-computes the results, BigQuery can often just serve the result from the MV, which is way cheaper and faster than rerunning the whole complex query every time.
It's like caching the expensive result.
Right.
And speaking of caching,
Right, BigQuery has automatic query caching. If you or someone else runs the exact same query within typically 24 hours, and the underlying data hasn't changed.
you get the result instantly, for free.
Well, free in terms of compute cost for that second run, it comes straight from the cache. And don't overlook BI Engine.
BI engine, that's the in-memory thing.
Yeah, it's an in-memory acceleration layer, particularly good for BI tools like Looker Studio. It can dramatically speed up queries and often lower costs for those interactive dashboard use cases.
Wow. Okay, so lots of technical levers to pull. Careful SQL, partitioning, clustering, MVs, caching, BI engine. It's quite a toolkit.
It really is. But using them effectively requires understanding your workloads.
Now, this isn't just on the shoulders of the individual engineer or analyst writing the query, is it? There's a bigger picture.
Oh, absolutely. This needs organizational buy-in. For business leaders, putting cost control on the agenda is essential. Adopting a FinOps approach is key here.
FinOps, finance, engineering, operations, all talking to each other about cloud spend.
Exactly that. Collaboration is crucial. It means regular spend reviews, making sure costs are attributed correctly using those labels we talked about, and building shared accountability.
And for the data professionals themselves, besides writing better SQL.
Their role is evolving. Understanding cost implications is becoming a core skill. This means things like consciously tuning slot usage. The compute units BigQuery uses, maybe using flex slots for predictable batch jobs, or proposing sensible data expiration policies based on actual usage patterns.
So everyone has a part to play. Leadership sets the strategy and fosters the culture, and the data teams implement the best practices on the ground.
It really is a team sport. You need the governance framework from the top and the technical know-how implemented day to day. That combination is what truly works.
It's about building that cost-aware mindset across the board.
Couldn't have said it better myself. A culture of cost consciousness.
Okay, great stuff. So, to wrap this up, maybe a final thought for you listening. Don't feel you need to boil the ocean overnight.
Good point.
Just think about one thing from our chat today. Could you set up just one budget alert? Could you review the SQL for your top 3 most expensive queries? Could you investigate partitioning for that one huge table?
Even starting small can make a real difference.
Exactly. Pick one thing. Implementing even one strategy can start you on the path to better control over your analytics spending and ultimately getting more value, more ROI from your data. Thanks for diving in with us.